Hello, bonjour, welcome and bienvenue. Today's tutorial for my science colleagues will illustrate how we can use the solver add-in in Excel to solve implicit equations if we set them up as a fitting problem. Now, one of my favorite implicit equations is the one shown here. This is sometimes called the Krippendorff equation, named after the first author of a 2009 publication where it was first derived. So IC50 values are frequently measured from endpoint product formation assays, but when the inhibitor in question is irreversible, the time of the endpoint assay will affect the value of the IC50 being measured. So the Krippendorff equation relates the time-dependent IC50 value to the Ki of the inhibitor, its Kinact value, and the time of the measurement. But you will note this is not an explicit equation, it's an implicit equation because IC50 appears on the left-hand side of the equation and on the right-hand side of the equation in the K-obs term. So that makes it very difficult to calculate the value of IC50 directly, but it is very easy to do if we use solver. So first, I've set up this spreadsheet with input cells for all of the different variables. That means I can change any one of the values and recalculate, allowing me to reuse this spreadsheet for any inhibitor. And this is best practice for Excel. You'll also note that to simplify some formulas, I've made some cells that contain intermediate formulas. For example, the so-called alpha term of 1 plus S over Km due to competition between the assay substrate and the inhibitor is multiplied by Ki to give Ki apparent, or apparent Ki. Also, K-obs is given by Kinact times inhibitor concentration, in this case IC50, over the Ki apparent plus that concentration. Now in the orange input cells, I've entered the values that we know from this assay and this inhibitor, but the IC50 value that you see here, the IC50 value that I entered, is just an initial estimate that will be replaced upon fitting. So the key to using Excel to solve an implicit equation is to separately calculate the left and right hand sides of the equation and then to calculate the difference between them. Now the left hand side of the Krippendorff equation is dead easy. It's simply equal to IC50 or C11. But the right hand side of the equation is really tricky and we have to type it carefully. It's equal to the Ki apparent, C9, times 2 minus 2 times e to the power of minus K-obs, or C12, times the time of the assay, C10. And this is divided by K-obs, C12, times the time of the assay, C10, and from all of this, subtract 1. Very important to get all of those brackets right. Now you can see that my initial estimate of IC50 is not correct because the left-hand side and the right-hand side of the equations are not equal. So let's calculate the difference between the right-hand side and left-hand side as right-hand side C16 minus left-hand side B16. And let's square the difference to amplify it and to get rid of any possible negative signs. So equals D16 to the power of 2. And now we're ready for solving. So I open Solver, Data, Solver, and I direct it to consider the value of E16, the squared difference, and I'm going to ask it to minimize this value because for a solved implicit equation, the difference between the left-hand side and right-hand side will be 0. And I direct Solver to change only the value of cell C11, the IC50 value, in order to set the two sides of the equation equal to each other. When I click Solve, Solver finds a solution nearly instantaneously where the difference between the two sides is essentially 0. So under these conditions, the IC50 value is 48 nanomolar. And if we were to change the time of the assay to 45 minutes, and then solve again, well, now you can see that the IC50 value is 2 nanomolar. And if we were to change the time of the assay to 5 minutes, the IC50 value is 16 nanomolar. Now, if you take the limits of the Krippendorff equation, you can show that as the assay time approaches 0, IC50 approaches Ki apparent. And you can show this numerically as well. But for those of you who are not specifically interested in irreversible enzyme inhibitors, and shame on you, the point of this exercise was to demonstrate that if you set up cells to calculate the left-hand side and the right-hand side of an implicit equation separately, you can ask Solver to find a value for one parameter for which the difference between these two sides will be 0. And in this way, you can use Excel to solve any implicit equation.